How are you, students? Can you hear my voice? Okay. Okay, students. So last day I have discussed on the chapter that is coordination chemistry. It is a vital chapter and very important topics are there. Okay, and lastly I have discussed some questions also, very simple questions regarding these chapters, and as there are much more topic there should be a varieties of questions will be there. Now today I will start the unit, that is unit 4. I will start unit 4. Okay. So unit 4, that is surface chemistry. Now we have the knowledge of surface. Now what the surface chemistry belongs? The surface chemistry is that generally there are surface, that means surface are of solid and liquid specifically, gases having no surface, and the solids having a very definite surface, liquid also having a definite surface when it placed in a container. Okay. Now the surface is can be separated, and we know what is surface tension, because surface tension is due to the pull, that is the inward pull of the surface molecule, that is due to the inward pull by the bulk to the outward molecule or outer surface. So it is the reason behind the surface tension. Now we can identify the surface very easily for the solids and also for the liquids, gases having no surface area, okay, because the molecules are discrete. Now solid having very definite bond in between them, these are called metallic bond. Okay, when we have come through the d orbit, there was the concept of metallic bonding, and in the liquids there are different kinds of bonding. There is hydrogen bonding, van der Waals forces is there, and van der Waals force, that is London force, these are there, and for this reason the liquids can be shaped, or liquid can be stored in a container, but gases cannot be do so. So the chemistry or the unit which describes about the surface of different substances, mainly the solids and liquids, that is the nature of the substance, okay, and any physical phenomenon occurred in the surface, these are discussed on this chapter, that is surface chemistry. Okay. Now the surface effects become even more significant when the surface under consideration is finely divided. Now what is the importance of finely divided surface? You can see that there is the catalyst used, that is finely divided palladium or finely divided platinum. Now what is the role of this? That is how what is the importance of finely divided? That is, here we can open the surfaces of the metal, and the bonding, that is we can open the free surfaces of the bond, and also the metallic character is open, so that the strong bonding is possible in that case. So when there is a definite arrangement is there and we break into sub parts, then the bond become different, that means they feel a certain deficiency in bonding because they were stable, but when the bonds are broken, that means very small parts is there, that is the metallic bond is broken, and then the surface becomes open to make a bond with other substances, and in that case we will get the here is the importance of surface chemistry. So it is mainly considered for the solids and liquid. Okay. Now the branch of chemistry which deals with the nature of the surface and species present on it. nature of the substance, nature of the surface, that means it is nature of the substance, that means it is a bonding type, that means it metallic bonding or any covalent bonding. This is the nature of the substance and nature of the surface. And second one, that is the any substance is present there. Okay. Now, any substance, that means as the bonding is open there, that is a deficiency in bond formation is there or the bond are broken, then the elements having or the atoms having in surface, they need some kind of stability, and for this reason in appropriate atmosphere or in appropriate condition, what they do, they take or they make a bond with external substances. This is told as the species present. So, nature of the substance, that means the bonding is possible there or any weak bonding, any strong bonding is possible there, and any species is present, that means any bonding is there. Okay. So, these things are discussed on this part, that is surface chemistry. Now, you know the colloid is there, colloid, it is a part of the solutions. Now, in colloidal suspension, there is the suspended particles are moving in around the solutions, and there are three types of solution. So, in colloid chemistry also we can see the applications of surface chemistry. Now, first of all, the surface chemistry, it mainly deals with adsorption and absorption. Now, later on the distinction between these two words will be there. So, first of all, what is adsorption? Now, the phenomenon of higher concentration of molecular species on the surface of the solid than in the bulk. So, what does it tells? That adsorption is that phenomenon where the concentration of any species in the surface will be greater than in the bulk. Bulk means the rest of the system. So, when the concentration of the species is higher in case of in the surface, it is called adsorption. Now, there are definite examples are there. We may call again, remember again the finely divided, that means when we increasing the surface, we opens the bond, that is the probability of formation of bond with such some other species. Okay. So, it is a phenomenon of higher concentration of any species in the surface is called the adsorption. Okay. Now, why the adsorption takes place? So, when a bond is there, that means here some kind of stability is there. That means when a energy is released by the system, it comes in the different form. So, adsorption always comes with the evolution of it. So, why? Because as the stability is there, when they mix a bond, any metallic bonding, that means a open surface of the palladium or platinum or copper is there, then the open surface make a bond with the external species, and there are some kind of stability is there, and for this reason this stability, that is the energy, that is the residual energy, is comes in the form of heat. So, adsorption is an exothermic process. Okay, and for exothermic process, delta H is negative. We know it from the thermodynamics. For exothermic process, delta H is negative, and later on I will prove that for Gibbs-Helmholtz equation how it is applicable. That means how the adsorption is applicable in case of adsorption. That means how free energy is decreased in case of adsorption. Okay. Now, what happens in that case? It cannot penetrate the bulk, that is the surface species cannot penetrate the bulk. Why? Because there is only affinity in the surfaces. If the affinity is only in the surface, not the bulk. Suppose the hydrogen gas, when hydrogen gas in palladium, it is palladium, this is hydrogen gas, and if we heat the medium, then what happens? The hydrogen gas evolve from the system. Okay. But when NH3 gas is passes over NH3 gas is passed over the solution of any water, then what happens? That is H2O, then what happens? It produces NH4OH, and the concentration of NH3 is same throughout the bulk. That means the water molecules taking the ammonia to make a uniform concentration of ammonia gas in the solution, but here the concentration of hydrogen gas will be there in the surfaces only, because the particles in the bulk is there, it does not carry the hydrogen gas throughout the bulk. Okay. So, this is the difference in between these, that is the adsorption and absorption, later it will be clear. Okay. So, it is only on the surfaces. Now, next point is that adsorbent and adsorbate. Adsorbent. The species, the substance which make a space or which making bond with the external species is called adsorbent. Here the palladium, platinum, nickel, the surfaces are used to make a bond with the hydrogen, that is the finely divided palladium, platinum, nickel is used to make bond with hydrogen, it is called, these are called adsorbent, and the substance, that external species which making bond with the adsorbent is called adsorbate. So, adsorbate is the, here it is the gaseous substance, that is hydrogen. Now, a number of gases like ammonia, phosgene, etc., it can be used as an adsorbate, and the adsorbent, if we take the example of dissolving ammonia in H2O, then H2O will be the adsorbent and NH3 will be the adsorbate. Okay. So, the external substance which making bond with the species is called the adsorbent, and the external substances or the species which takes part in the surface or throughout the bulk is called the adsorbate. So, this is the two important terms, what is adsorbent and what is adsorbate. Now, one physical experiment we can say that animal charcoal when it is used in case of, suppose in a litmus solution, okay, and also in the decolorizing agent, then you can see that the animal charcoal, it as it having a the gas absorbing, the color absorbing capacity. So, it can absorb the gas or it can absorb the color, that means it can decolorize the medium, that means in the case of decolorizing of sugar, decolorizing of sugar, here animal charcoal is used to decolorize the sugar, because the animal charcoal absorb the coloring substance present in that and make a fresh color to the sugar. Okay. Next, how we can prove that adsorption takes place. Okay. Now, the gases like carbon dioxide, sulfur dioxide, ammonia I have already told, and carbon monoxide, when they are kept in a vessel, that means in an enclosed vessel, they give a pressure. Okay. Now, if we add some adsorbing substances, that means the adsorbent there, then after some time it is possible that if it is possible to measure the pressure, then you can see that there is a decrease of pressure, and for this reason we can told that the gases which was there and it is adsorbed by the adsorbent, and for this reason there is a decrease of pressure, and it is found experimentally that the gas decrease in pressure of the system. That means the gases like carbon monoxide, SO2, NH3 kept in an enclosed vessel, that is in closed system, and pressure is measured P, and if we add some animal charcoal, and after adding animal charcoal, after some time if we measure the pressure, then we can see that the pressure is decreased. It is one real example of adsorption. Another one example we may take, that is organic dyes, for example blue litmus. When blue litmus is placed or a pinch of animal charcoal is placed or dropped on the blue litmus solution in diluted form, the charcoal adsorbs the amount of blue dye and the color of the dye is somehow fade. It is also one example of adsorption. Okay. And also I have told you in the decolorizing of sugar, that means in sugar industry for the decolorization of, that is from the brown color, generally the sugar obtained are of brown color, and it for decolorizing here the animal charcoal is used. So, these are the real examples of adsorption. Now, next point is that, have you understood? That is I have already discussed what is the surface chemistry, that is it deals with the surface, that means nature of the surface, and also the species, any species is present there. Next one as the adsorption, that means when the concentration of the external species is higher on the surface is called the adsorption. Mainly it is the gas will be the adsorbate, and the liquid and solid is the adsorbent. Okay. Now, adsorption, and lastly there are two terms, one is adsorption, adsorbate, and another one is adsorbent. Okay. Now, there was some real example, that is how the animal charcoal or some substances, liquids can work as a adsorbent. Next one is the how adsorption takes place, mechanism of adsorption. So, for this we will take the examples of the finely divided metal. Okay, when a metal in intact form, here a strong bonding is there, that is metal bonding is there, but if we use, this is the in the elemental form, or we may call it crude form, and when a finely divided metal is there, then these are open, that means this bond is open. Okay. So, as the bonds is open, so there is the chance, and also we know that metal having the vacant d orbital, and for this reason they mix bond with the substances like hydrogen. It is also a types of bonding which will be discussed later on, but as the bonds is open, so here the chance of any external species may bond is there. The adsorbent which are commonly used are activated charcoal, the adsorbent which is used, that is activated charcoal, animal charcoal, silica gel. Okay. So, activated charcoal, animal charcoal, activated charcoal, that means here it is done by in high pressure, and also as an temperature is there to release the gases which is present there, to carbon dioxide, C2H4, these gases are present there. To remove this particle, it is used and removing of this carbon monoxide C2H4, and this is called activated charcoal. Activated charcoal, animal charcoal, silica gel, finely divided copper, palladium, etc. and etc. So, these substances can work as an adsorbent. Okay. So, activated charcoal, it is made after the removal of CO, CO2, C2H4, etc., any substances present. Animal charcoal, which is formed by the burning of the animal bone. Next one, silica gel, and finely divided copper, palladium, etc., and nickel also there. Okay. So, these can work as an adsorbent. You may also write this, what acts as adsorbent. Okay. So, next it would be what is positive and negative adsorption. Okay. Now, positive adsorption is that when the concentration of the species or the adsorbate is on the surface, it is maximum in the surface, it is called positive adsorption, and when it is on the bulk, that means it is less in the surface, is called the negative adsorption. Okay. For example, the concentrated solution of KOH, the concentrated solution of KCl is taken with bone charcoal, then it will produce a positive adsorption, and when an aqueous solution of KCl is dissolved in a solution of anisole charcoal, then it will produce the negative adsorption. Next one, that is desorption. What is desorption? I have told that desorption is that the removal of adsorbate, from adsorbent. Removal of adsorbate from adsorbent. Okay. Now, when a hydrogen is adsorbed, in palladium, then if we heat it, then it is only weak interaction is there. Sometimes it is van der Waals forces is there, and when we heat it, the bond become weakened and the adsorbate will come out from the adsorbent. So, it is called desorption, that is the desorption of removal of the adsorbate from adsorbent. Okay. So, this is the second, that is what is desorption, that is removal of adsorption. What are the agent? Agent is that heat. Heat is the one agent which may weakens the bond. Okay. So, the important points here was the what is adsorption and what is the adsorbate and adsorbent. Next one, what are the species which can work as adsorption, that is adsorbent, and which can work as adsorbate, and later on what is desorption and desorption, what is desorption. Okay. Any problem? This chapter, first chapter, this is the preliminary chapter and it is theoretical part. Any problem out of this? Any problem, students? Pause. Okay, very good. Thank you, students. Wait for the next class.